Hello, everyone. I'm Sonal Sinha, and along with me is the co-presenter Siddharth Singh for the paper that is Annotated Speech Corpus for Low-Resource Indian Languages, that is Awadhi, Bhojpuri, Braj and Magahi. For the presentations, we will start with introduction.
Sonal, I
Siddharth,
think
please.
we're okay. Yeah. Please go into that. I thought you were in the slideshow mode. We were not seeing that. Please go ahead. Sorry.
Okay. Okay, so for the presentations, we will start with an introduction, language demography, dataset preparation, experimental setup, ethical and societal implications, and lastly, the summary. For the introduction, developing reliable speech technology for several Indian languages has been challenges as there are low resources. And although many automatic speech recognition systems have been built for several major languages of India, like Hindi, Marathi, Telugu, etc., still there is a lack of transcribed speech corpus and models for several other languages. To overcome this absence of these low resources of data, many initiatives have been taken for several projects and teams in recent times like ours. For language demography, so we will start with our objectives. The objectives is transcribed speech corpus and ASR for, please go to the next slide. Yeah, and ASR for these languages. So we'll start with a language demography. Here is a demography of the Indo-Aryan language family on which we are working, that is Awadhi, and the native speakers are 3.85 million, and they are specially spoken in Awadh region of Uttar Pradesh. For Bhojpuri, we have 51 million native speakers, and it is basically spoken in Western Bihar, Eastern Uttar Pradesh, Western Jharkhand, Northeastern Madhya Pradesh, and Chhattisgarh and Nepal. For dataset preparations, the data collection holds an important and fun part actually for the paper, and we have collected speech data for 4 languages, as already said, and it was done recorded via the Karya app, which is a mobile-based crowdsourcing tool, specially aimed at generating income for low resource and for low income groups by providing them opportunities to work on the crowd-based tasks. It works offline. And this is the merge of fieldwork and crowdsourcing, as the sentences were presented on the interference once at a time and asked for its translations, as we do in the field, indicating the pictures and objects to the speakers. So this is the interface of the Karya app. The source language is already uploaded on the this app, and have to be translated and recorded each sentence into the respective languages, that is Braj, Awadhi, Magahi, and Bhojpuri. And in order to get the clean data, we ask the speakers to avoid the places where birds are chirping and there is noise of traffic and other family chit chats. So for the speaker details, we selected 40 language experts, male and female in equal ratio, and 10 from each language, and they were all above 18 years and between 70 years, 60 years. And the regions were districts of Bihar and Uttar Pradesh. Like for Awadhi, they were from Pratapgarh, Uttar Pradesh, and Eastern Uttar Pradesh basically. And for Bhojpuri, they were from Patna, Sasaram of Bihar, and Varanasi, Balia from Uttar Pradesh. For Braj, they were from Agra, Uttar Pradesh. And for Magahi, they were basically from Patna district of Bihar. And the speakers were both monolingual and multilingual. For the questionnaire method, we use a questionnaire method actually. We recorded the speech using these methods that is used by field linguists for the data collection. The questionnaires are utilized for grammatical descriptions of a specific phenomena and possibly of the language as a whole, and for generating ASR models. This is not generally possible with any random text, so we choose this. Since the languages under the current study are not only under-resourced, but are underrepresented, minoritized, and devalued by mistakenly seen as dialects of Hindi, which they are not. And the data collection involved two independent phases, the translation phase and the narration phase. Here also is a given link for the questionnaire from which we collected the data. So for the translation phase, we provided 369 sentences in Hindi on the domain of daily routine for life situations like domestic work, food, cooking, etc., and asked the speakers to record and translation of these sentences into their respective languages. More importantly, these sentences have been designed to elicit patterns of a large number of grammatical phenomena, such as case, reflexives, classifiers, reciprocals, tense, mood, etc. And this allowed us not only to get data for describing the different phenomena in the language, but also got representation of various kinds of sentences in the data sets. For the narration phase, we prepared 39 questions, and these questions were related mainly to the life cycles events of our culture, that is starting from birth, marriage, and death. These questions were prompts asking the speakers to talk about the rituals and tradition related to these events, and this gave narrative data and also allowed us to collect those kinds of sentences that were not possible to elicit via the translations only. So for further works, I should call Siddharth to explain more.
I'm facing some issue with the Zoom application. As soon as I started speaking, the volume come down. So the speech data which we have collected is shown in the table. We managed to collect 18 hours of total data, including translation and narration. And in all 4 languages, there are 4 to 5 hours of data we managed to collect, in which there are 8 hours 30 minutes of data translation, and narration data is 9 hours 30 minutes. And this is the pictorial data. Magahi is the most number of hours in translation, and in the narration data set we have Awadhi as the most in the narration data, and Braj similar, both have similar numbers. And this is the overall data set including translation and narration data. And this graph showing the total translation sentence and the tokens in the data. So one thing we can draw from this is that the difference between the translation and the narration is that when the speaker is given to speak on some topic, so the narration data managed to get more number of tokens, as there in the translation there are fixed number of words, and the tokens are comparatively less as we compare the number of sentences in both the phases. So if with the aim to develop ASR systems, and the narration, if we are collecting the narration data, then we get the more number of tokens for the languages, and we will be able to build the more better ASR systems. So, and there was some issues also with the narration data, that speakers were like some speakers were not like, if the younger generations, they were not very much aware of the cultural references regarding the birth, like when a child is born in the community, what are the rituals that perform. So they were not able to give that much of input. So that is one issue with the narration part of the data. And then we have with the data which we have collected, we have done some basic experiments in the context of building the SR system. So we have divided the whole data set into 80-20 ratio, train and test. And we have used 3 approaches for the testing the ASR system. So first approach, we use the 2 Hindi ASR systems. One is by Google and then is by Azure Microsoft. We have just give our test data to these systems and calculated the word error rate. And in the Second approach, we have trained a Kaldi recipe from scratch using our train and test data. And in the third approach, we use the transfer learning, the web-to-web model to test the performance of on these data sets, SR systems performance. So the last two approaches, we have set up two different setups. One is for training and testing on the monolingual data, like for each languages we have trained and test on the both approaches, on the Kaldi and the transfer learning method. And for the second setup, we have combined all the data, all 4 languages data, and trained a multilingual system, and test on, also we have tested on the multilingual system, multilingual data. So what we have got from this whole experiment is that web to web model nearly, there is a difference of nearly 50% in word error. Like if Kaldi is giving 80% of word error rate on the 4 hours of data of Awadhi, 4 hours of data of Bhojpuri. So web to web is nearly giving 30 for around 40%. So this table summarizes the whole experiment and the word error rates. So we can see that in web to web we get the best results, like the minimum least word error rates. And for multilingual setup in web to web, we have only used these 3 languages, Bhojpuri, Braj and Magahi, and we have managed to get around 40% of word error rate with on multilingual setup. So, and some societal implication of this whole collecting data and this whole project is that we collected this data during the COVID-19 time. So with whatever means, we managed to help the community it's in a financial way. Like COVID-19 was a tough time for everybody, and especially for the lower income group of the society. So we have managed to help in whatever way we can through this data collection process. And second was that the possible enhancement of the language prestige. Like these languages are mostly spoken around Hindi, like Hindi is very prominent in these regions, but these languages have their own identity. But when we ask the native speakers to that, like we're collecting this data in Bhojpuri or in Awadhi, they were like kind of unsure that they don't speak Awadhi or they speak Hindi. But through some convincing, they managed to collect the data, do the translation, and do the narration part in their native language. And after the whole process, they were kind of feeling good about that. Yeah, there are some thing happening in their language, and they were more accepting their own native language. So the application of the data set is that, of course, we can, these all languages are mainly in spoken form. So ASR will be a good application for these languages. And also the data could be collected in with the purpose that it could also be used to study the languages, the linguistic features of the languages, phonetics, phonology, morphology, and other linguistic features. So it will be used by both the NLP practitioners and the field linguist and the linguist equally. And thank you for your time. And the data set is available at this GitHub link. And for questionnaire, you can mail us. We can share the questionnaire which we have used, and for any query. Thank you for your time.
Thank you very much, Siddharth and Sonal. Right, we have time for some questions.
Yeah, network issue.
I have a question. First, I'm quite impressed that you can collect these smaller languages. It's quite important to do it. I am sort of aware of these languages, and I'm aware that the people that you're collecting from also speak Hindi, or as you say, think that they speak Hindi, but it's some type of Hindi. So you actually had them read Hindi then would translate it. So they had to be literate in Hindi to do that. Is that correct?
Yeah, Alan, it's correct. They were both monolingual. Sorry, they were actually bilingual and multilingual as well. So
Okay.
all of them knew Hindi, and
Yeah.
other than that, Awadhi was the native language, and Braj was the native language like that.
Okay, that's good. And I think that's a very good way to try to collect that, because it means you don't have to translate everything into languages you may not have resources for. But then the next question is, how much do you think the fact that they were in a Hindi environment influenced the way they pronounced their native language? Do you think it made it more Hindi-like, or do you think that they managed to partition Hindi to their particular native language?
Actually, yeah, there are some influences, but not much. They were mostly the native speakers. So we chose those speakers that were residing in that particular area for a very long time, so that they were actual native speakers. So we managed to find those people.
Okay, good. Okay, thank you.
Thank you.
Judith, please
Any
go
more
ahead.
questions?
Yeah, no, fascinating. And I love the way that you said at the end that the speakers are kind of more proud of their language because of what you're doing. I think that's absolutely fantastic. I'm just curious to know what you see the next steps for improving the ASR, the word error rate, because obviously at where it is at the moment, it's still not really very useful for practical applications. So it needs to get a bit better. What are you doing next?
I think Siddharth would be a more good candidate to answer that.
Yeah, so for the Kaldi, we are trying to make we have used some language models with data as a language model for them for these languages, but we have used the Hindi. We have used the Hindi grapheme to phoneme mapping. So we will try to integrate these languages phonemes. So that will be one place where we can improve the Kaldi system, and more language model for these languages will be an improvement which we are thinking of, and more data, of course, more data. So we are in process of collecting more data, so we will add this data to the already set pipeline.
Are there many distinct phonemes in these languages compared to Hindi? Are there, is it, yeah. I don't know if that's a question you could answer. But
yeah, we haven't looked at that way, but we haven't looked at in detail about that there is some extra sounds apart from Hindi, but we will have to do that analysis, then only we can. While listening, we get that there is some different sounds or combination of sounds. There are some, but we have to do the analysis for getting the full picture.
That'll be interesting work. Thank you.
Yeah, thanks. One last question before I wrap up, and you may stop sharing your screen so Judith can start projecting. Judith, I hope the next speaker, right? Right. So Siddharth, I had one question. So when you're reporting the word error rates on the Google and the Microsoft Azure, were you changing the vocabulary and the language models to do that recognition?
No, we have used the language model for these languages and added to give some data to support the system.
Okay.
So sorry if I could intervene. So we actually did, I think for one of the models, they allowed us to augment the vocabulary with with the specialized, I think it was Azure which allowed us to augment the vocabulary with a specialized vocabulary or something. And so we used that for augmenting that with the transcriptions that we had. So we gave the transcriptions in that.
Okay, great. So